Okay, students, what I'd like to do with you is just to use a little bit of technology to help you to understand means and standard deviations. So remember, having the mean is pretty meaningless without the standard deviation. So what I would like to do is just calculate the mean with you on Microsoft Excel. So I've just inputted a bunch of data, and what I'm going to do is calculate the average for the first lot. So, for example, this was a class of students, and you can see in the first test out of 40, the class averaged 23.25 out of 40. Now, let's have a look how this is going. We've got 24, so it's gone up a little bit, 22, it's gone down a little bit, and 22.9. So the mean has stayed around 23 for each of these. Gone down a little bit there and gone up a little bit there. What I'd like to do is also just calculate the standard deviation. And to do that, it's going to be another Excel function. So we're going to go here, we'll go more functions. In here, we'll type in standard deviation, and we want to go to statistical too, I suppose. So standard deviation, and let's have a look. That's not being very nice. Let's try this again. Statistical. Oh, well, let's just go down to here, and we'll go. Okay, what's this one? This estimates the standard deviation based on a sample. It ignores the logical values. That's just letters and so on. Okay. Do we want the sample standard deviation or the population standard deviation? We want the population one because we're going to calculate it for the whole class. So we go, select that one, and then we just select the cells. So we see here, we can just choose these ones here. So, and then just go OK. So let's just shrink that down a little bit. So we've got a mean of 23.25 with a standard deviation of 12. So that's quite a big variation. And let's just analyze each of these. So if I have a look at these, I've got a pretty good mean, even better mean here. But the variation within the scores is a whole lot bigger than these two here. If I have a look here, the scores are a whole lot more close together to the mean. I could probably also just quickly show you this on a box plot, and just to reinforce this issue of how the data is clustered and spread out. And so you can see that although the box and whisker plots is a use of quartiles and medians, it will also show you the spread of the data. In fact, on here we can see the X is representing the mean. The standard deviation also is reflected into the interquartile range here. The size of these boxes is that the first two tests there was big variability. The second two tests there was less variability.